What are the different solver controls when we run a transient simulation? For solver control, there are transient schemes. You only need to enter the value of maximum coefficient loops, which is the maximum number of iterations per time step. Choose between 3 to 5 for reasonable time step. For well-selected number of coefficient loops, the outer loop iteration should be close to convergence at the given time step. These are the options for the convergence control. If the convergence for a particular time instant shows unsatisfactory level, reduce the time step rather than increasing the number of coefficient loops. Default transient scheme is good, that is second order backward Euler. Default turbulence numerics is also appropriate, that is first order. Default volume fraction numerics is bounded second order. Now let us review the transient results file. In the solver output control, we can click edit. We have to go to output control of the solver and click on edit. This is used whenever we want to create any type of animation as function of time. So in this case, there is a tab in the output control which is called as transient results. This means when the solution is progressing, what sort of transient files you have to write after some specified time instance. Options are selected variables. Results for selected variables will be written. No restart is possible from these files. Second is smallest, which means mesh data and all solution vertex fields will be written. Restart is possible, but initially might show some jump in the residuals. Essential, which means the smallest file that preserves a clean restart is written. Data that is written is mesh data, GGI control surface fields, boundary phase solution arrays, and interphase mass flows. These are the three results file writing options, which means after some specified number of time instants or time steps, what files, transient files will be written. That is transient result file. Standard is another option, which means apart from data written in essential category, additional data will be written, which is hybrid fields, post-processing fields, and mass flow data fields. Continuing our discussion on transient result files, mesh may or may not be included when we write the transient result files. There is another option, which is output equation residual and output boundary flows. Output boundary flows, if we click on that, it will include by default for standard option. This is included by default for standard option. It should be enabled for selected variables and smallest transient files. Accurate calculation of source, heat flows, and mass flows will be done, and it writes this particular data in the transient result file. Output frequency, it can be a constant or value or a CFX expression. Several options are available. This means after how many iterations or number of time steps the transient files will be written. After this, there is another tab called as transient statistics in the output control dialog box. The statistical analysis of any variable is possible throughout the transient analysis. Options are minimum, maximum, arithmetic average, root mean square, and standard deviation. What this means is, for transient simulations, a variable will have different values at every time instance. But if we want average quantities like arithmetic average, root mean square average, what is the standard deviation, what is the maximum value of temperature throughout the simulation, then we can write those by using this output transient statistics control output option. All the solution variables available in the output variable section, that is this particular section. Optionally provided start-stop iteration list is also there. That is, instead of calculating for the entire simulation, we can calculate from 20th second to 40th second, something like that. Iteration number specifies the time step index. Restart of running statistics is possible. Accumulated time step index rather than the index for the current run will be used in case of restart. Let us see how the solver output file in the CFX solver differs when we run a transient simulation. Output differs from steady state in that each iteration now contains coefficient loops. The user should make sure reasonable convergence has been achieved by monitoring the RMS and maximum residual for the coefficient loop iteration within one time step also. Time step should be reduced if convergence criteria for time step are not met by last coefficient loop. When we analyze results of transient simulation, what are the different options? We will see that in this particular slide. To visualize the transient results, load the final.res file into CFX post. We can use the transient time step selector to look at different time step instance. So transient time step selector can be used. This opens a particular time step selector dialog box, and then after time steps we have all the data saved that is there. Just click on this time step and the result of this time step will be opened. The animation wizard can be used to make transient animations easily. So summary of this particular session, we saw transient simulations, we saw how to set up a transient simulation in CFX Pre, what are the different options, what is the requirement of running a transient simulation, how CFX solver changes when we run a transient simulation, and what are the different results entities in CFD post when we run a transient simulation. Transient simulation requires special care for time step, duration, solver control and output control. Unsteady simulations require initial boundary conditions apart from the boundary conditions that we specify for steady state. Often it is a good practice to use the steady state result as an initial condition for transient simulations. So thank you for attending this particular lecture. See you in the next session of this course on CFD modeling using CFX by LearnCAX.